Okay, we're going to get started. This is going to be a brief tutorial to assist you out with your homework. It is on representations of functions, lesson 6.2. This is not a complete lesson. This is just a brief lesson to assist you with your homework, which was assigned by your teacher on Thursday, January 8, 2015. Just in case you did not write your homework down or you forgot it, it is listed here on the board. It is page 253, number 19 through 24. And just in case you need a minute to write it down, go ahead. Okay, you may rewind it, pause it, come back to it at your convenience. I've already drawn some of the charts that we will be using today. Our step one problem, direction state, graph the function. Here we have an equation, y equals x plus 7. Step one, we're going to make a chart. So we're trying to determine what our y value is. So it says that y is equal to x plus 7. Now we're just going to use some common numbers that Ms. Matheny advised you all to use in class, which were 1, 0, and negative 1. Those are going to be our x values. We're going to substitute those values for x, and we're going to solve for our y. So our next thing that we need to do is just substitute it into our problem. So x for our first block is 1. So we're going to say 1 plus 7. 1 plus 7 is equal to 8. Okay, on our next one, we have x as 0. So we're going to substitute again. 0 plus 7 is equal to 7. And our last one, negative 1. Negative 1 plus 7 is equal to 6. Just before we go ahead to step 2, I do want to reinforce something with our last little problem here. We are adding terms with unlike signs. The rule here is to subtract and take the sign of our largest number. So when we subtract, that will be 7 minus 1, which gave us 6, and our largest number here is 7, and it is positive. That's why our 6 is positive. Now we're going to come over, and we are going to list our ordered pairs. When you list your ordered pairs, you put your x first and your y second. So our first ordered pair is 1, 8. Our second ordered pair is 0, 7. And our third ordered pair is negative 1, 6. And this came from our chart in step 1. Look under your column for x and your column for y to come up with those ordered pairs. Now we're just simply going to graph it. So our first ordered pair is 1, 8. So that's going to go over to a positive 1 and go up 8. So that's 1, 2, 3, 4, 5, 6, 7. We don't have enough, but 8 would be right here. Our second one would be 0, 7. So 0 and then go up to 7. And our final one is negative 1 and 6. That's it. And you will draw your line connecting your dots and make sure you put your arrows on the end. Now my line may not be straight, so just bear with me. And that is it. That's all you have to do for your homework. Not hard, huh?
Does it matter for the x for step 1 and what order do you put it, like negative 1, 0, positive 1?
It's not going to matter because your line will still form the same way. So if you did negative 1, 6, 0, 7, and 1, 8, you still would apply at the same points, and once you connect them together, the line still will move the same way. Are there any other questions? Are there any other questions? Okay, very well. on to our second problem. Now, our second problem, I decided to use a fraction. Now, because it is a fraction, I know some of you all may be nervous and said, oh no, I don't want to do that one. Guess what? You're going to do it anyway. Directions are still the same. Graph your function. We're going to do those same steps. I actually just copied this page and redid the numbers because we're going to use the same steps to do this. The only thing that we're going to do different is pick a different number for our x value. Because this is a fraction, we're going to take our denominator and we're going to use it as our x value. That's not working, so I'm just going to circle it. Our denominator here is 4. That still didn't work, did it? Our denominator here is 4. That's better. So we're going to take 4 and we're going to use it. So we're going to use positive 4. We're going to still use 0 and we're going to use negative 4. We're only going to use this technique when there is a fraction. If it is a whole number, we're going to continue to use negative 1, 0, and 1, or 1, 0, negative 1, same thing. But if it is a fraction, you're going to take that denominator, use the positive and negative of it, as well as 0. So for our first one, we are going to substitute for our x values and solve. So we have 3/4 times 4. I'm going to put a parentheses around it because that's what we need to do first, plus 2. Now, 3/4 times 4 plus 2. Our 4's will cancel out. That will leave us with 3. 3 plus 2 is equal to 5. And I'm going to come out to the side just in case you're not really sure how we came up with the multiplication for it. I will show you actually how to do the multiplication for a fraction out to the side. So what we did, we took 3/4, and this is called cross cancellation. We're going to cancel it out. 3 over 1, because now that's 3 over 1 is just equal to 3. Now we added that to our 2. We're going to do the same thing for the bottom. And this one is kind of easy because it's 0. And any number times 0 is what?
0.
0. So 3/4 times 0 plus 2. 3/4 times 0 is 0. 0 plus 2 will give us 2. Now, our final problem, 3/4 times negative 4. Please make sure you keep up with your negatives and positives, plus 2. We're going to use that same step we used before, which is our cross cancellation. The 4's will cancel out, and that is now 3 times a negative 1. That will give us a negative 3. Negative 3 plus 2, we have unlike terms, a negative and a positive, so we will subtract. 3 minus 2 will give us 1. And that will be a negative 1 because our 3 was negative. So again, that's negative 3 plus 2. These are unlike signs. You will subtract and take the sign of your largest number, which is 1. Now we are going to list our ordered pairs. Our first ordered pair is 4, 5. Our second ordered pair is 0, 2. And our final ordered pair is negative 4, negative 1. Okay, now we're going to plot these. So we have 4, 5. You're going to go 4 on your x-axis. That's positive. 1, 2, 3, 4. And up 5. 1, 2, 3, 4, 5. We're going to go 0 on our x-axis, which is where they intersect. Our x's intersect. We're going to go up 2. We're going to go over to -4 on our x-axis and down -1. So it's 1, 2, 3, 4, and down 1. And now we will connect our points. And that's all you have to do. That's it. Do you have any questions about this problem? Any questions? Any questions? Okay, so now all you have to do is just do your homework. Please do not disappoint me or yourself by not doing your homework tonight.
I got a question.
Yes, what is your question? Where? Here or here? This right here? The question is, where did I get the 1 that I have placed under my -4 at the bottom? And I'll just try to draw an error. He's asking about this 1. Any whole number. Wesley, do not be rude. A whole number has a denominator of 1. So any whole number, 4 can be written as 4 over 1. Example, number -2 can be written as -2 over 1. So that's where that 1 came from. Any whole number can be written as that number over 1. So any whole number can be written as a phrase. You just put a 1 up under it. Are there any other questions? Okay, well, we're going to stop here. Should you have any questions, refer back to the video, and also you may give me a call should you have